Okay, we already finished chapter 25, which is fundamental of the building. Today, we're going to talk about, or we're going to start chapter 26 in welding. So chapter 25 already finished. Today, we're going to start chapter 26 in a welding, which is a welding processes. So chapter 26 is a welding processes. We're going here in this chapter to cover arc welding, resistance welding, oxfoil gas welding, weld quality, design consideration in welding. This is the items that we're going to cover here in this chapter, chapter 26. Okay, so to remind you, in a welding generally we have whatever we call vision welding and solid state welding. I believe you understand what that means. Vision welding is liquid state welding, meaning we melt the welding zone for both substrate material. You get liquid mix, while solidification well done. Solid state welding, no melting at all. It's cold welding. Probably we can heat also, but less than melting temperature, usually zero point 0.5 melting temperature or something, just to activate or to encourage the atom to migrate from one material to other. Then bond will be created. Then weld will be done. This is the two category of the weld that we discussed last chapter in chapter 25: vision welding and solid state welding. Right. I start with arc welding as one type of the vision welding. Vision welding. So arc welding. Arc welding is a vision welding process. You know that. Arc welding is a vision welding process. Here, this is electrode. This is a workpiece. This is the filler. Probably electrode itself will be filler. We connect the electrode and workpiece by electricity here. When we connect the electrode and workpiece with the electricity, this charge will happen. When you connect the electrode and workpiece with the electricity and come closer, come closer and more closer and more closer. When you reach certain distance, become very close to the workpiece, this charge will happen. This charge, electrical discharge happen between electrode and workpiece. This is kind of waste in electrical energy or electrical energy loss. So electrical energy converted to thermal energy. This whatever we call arc welding. Arc welding. Arc will be created. This charge happen between electrode and workpiece is the arc. Arc will be created, which is a discharge between electrode and workpiece. And then electrical energy will be thermal energy. Temperature will increase up to melting the workpiece material. Welding zone only, not all workpiece material, definitely. Just only welding zone in a workpiece material. Then you get liquid mix, and then weld. Right. This is the arc welding, as I said. So electrical, it is this is charge of electrical current. It is mainly, if you would like to identify, it is the charge for electrical current. So arc is the discharge of electrical current. We call it arc in a gap between the electrode and workpiece. That's it. So this one temperature will increase. You melt the substrate material, and then you get well done. This is arc welding. However, arc welding as a one type of vision welding. And to remind you, when I said vision welding, you need heat. Mainly you need heat to melt the welding zone in a substrate material. It could be done by arc welding, gas welding, flame welding, gas welding, maybe resistance welding. So all this type, it doesn't matter what this type, but finally all these methods, heating the substrate material to get liquid mix. This is the main idea. In arc welding, the problem associated with arc welding or disadvantages of arc welding is the weld joint quality and the productivity. Why? Because arc welding is manual welding. Generally, arc welding is manual welding. So weld joint quality, it means that quality different from weld to weld because the human here. This is a human interfering the weld. So human doing the welding. Operator all time. It is manual. So weld quality is different. Not like robot arm. Do you remember that the video that I showed you last time? Not like the robot arm developing same quality for every joint, right? Here is different because it is manually. So weld quality is an issue. And also productivity. Productivity is low. Why productivity is low? Because it is manual. Then because it is manual, productivity is low. This is related to whatever we call arc time. Arc time means time arc is on. During the process, time arc is on. Because this one manual, because this manual, for manual welding, only 20% time arc is on. Only 20%, only 20% in manual welding. In manual welding, I can see here, in manual welding, only 20% time or arc 20% of the time arc is on. What about the 80%? Waste. Technician prepare, technician adjust the welding and so on, loading, unloading, remove the previous, bring the new ones, and you can see that waste of time. Big waste of time in a manual welding. That's why productivity is low. However, in machine welding or automated welding, arc time increase up to 50%. You can see that it is highly improved in automated welding or machine welding, right? In arc welding, there are two type of arc welding. Two type of arc welding. The first one, please give me your attention. The first one we call it is consumable electrode arc welding. The other one or second one we call it is non-consumable electrode arc welding. Consumable electrode arc welding is the electrode will be consumed. Consumed mean will be depleted because it will be melted. This is a consumable electrode. This is the electrode, guys. This is the electrode. So when said consumable electrode, this is the electrode, right? Consumable electrode. With this one, non-consumable electrode also. This is the electrode. So this one consumable electrode, this one non-consumable electrode. What does that mean? Consumable electrode, this electrode, please give me your attention, please. Please give me your attention. Consumable electrode meaning electrode made, as I told you, this process, which is vision, generally, vision welding process is limited only and only and only for similar material. Remember, please remember all time, vision welding generally is limited to similar material. What about electrode? What about the filler? Filler must be also used as a compatible material with the base material. Here in a consumable electrode, the electrode itself will be filler. Electrode itself will work as a filler. So it will be electrode and filler. This electrode will be melted. Here, temperature increase, electrode will be melted and deposited as a filler. So this one we call consumable because after time this one will be consumed. You need to change and replace another one and so on. This one consumable electrode. Non-consumable electrode, electrode not melted. Someone will ask me, not melted, what does that mean? Electrode here made of tungsten. Tungsten. Why tungsten? Because tungsten here is high melting temperature material, very high melting temperature material, 3500 plus, very high melting temperature, 3500 degrees Celsius plus. So it is very high melting temperature. Then when you do welding process, the electrode will not be melted and deposited in the filler as a filler material. So what we can do, added separate filler material. So filler material must be added separately. This is a filler material. So in the first case, electrode, it worked as a filler itself. It melted and deposited as a filler. In second case, electrode made of tungsten. Remember, only tungsten. And you can see that. In non-consumable electrodes, the electrode can be used for several welds. It doesn't matter what you're welding. You're welding aluminum, use electrode of tungsten. You're melting copper, use a tungsten. You're melting steel, use tungsten. Why? Because here the electrode will not melted and deposited here as a filler. Filler must be added separately. This is a filler must be added separately. This one wire, it will be melted and deposited in a well. Is it clear? This is consumable electrode. This is non-consumable. Then remember, arc welding, we have consumable electrode and non-consumable electrode, right? Start with the consumable electrode. Start with consumable electrode, where electrode will be melted and deposited as a filler. Then when it melted, electrode will be melted and deposited as the filler. This is the electrode. I believe most of you know the electrode. This is a machine. This is a holder. This is the electrode holder here. This is the electrode. You hold the electrode here, and then this one is the electrode. This electrode is a filler. The black one here is a filler. The black color here, this is a filler material. The material that will be melted and deposited. What is the white color one? The white color one is a filler material. Is the flux material. Coated with flux. This flux, which is white color material, this flux will be melted also and deposited together with filler material, and this flux will react with gases and environment to create slag, and this slag will protect the weld from further chemical reaction with the environment. So this is a flux. Similar to what we discussed in a casting, we said that we added flux in the casting. The casting, very important to add flux to react with the gases and environment to protect the casting from the further chemical reaction. Same also here. This is a flux being added or coated the filler material. Filler will deposit, flux will be melted and create gas. This gas here will shield. Shield means protect the weld from further chemical reaction with the environment. This is a consumable electrode, right? So you can see that consumable. This is a machine. This is a holder. This is the electrode holder. This is the electrode. This is the electrode holder. Here, melted. You can see that. This is a flux. This is a filler material. The core is a filler material. The coated is a flux. This one here is melted and create gas. This one, which is a coat, create gas. This gas react with the environment and create whatever we call slag. And the core will be melted and deposited as a filler material, as you can see here. Right. So this is generally consumable electrode. This is generally consumable electrode. I think I saw your video before. Let me show you again one more time. Just give me a second. Okay. I don't know what is the problem. Did you get it? I believe not, right? Just give me a second. I'll try again. Okay. Why? Can you see the video?
No, doctor.
I don't know why. I'm trying, but I don't know what is the problem. Did you get it? Now you can see, right?
Yes.
Now you can see this is the arc welding. I think I saw you this one before.
I can't see. No, it's okay. No,
Yeah,
it's okay.
right. So this is arc welding, as you can see here, discharge, electrical discharge here. This is a filler. The coating here, this is a coating. This is a coating actually. The core is a filler. You see that? Core here will melt, deposit. This filler, this is a filler, right? Will melted and deposit. The filler will melted and deposited here as a filler material. It is consumable. That's why I said it is consumable electrode. This is the coating. Coating is a flux material. Coating here, guys, is a flux. This coating also will be evaporated and create gas. Create gas surrounding. Gas, this gas mainly to react. This gas mainly to react with the environment to protect this one. To protect the welding in the electrical arc welding, right? You see, this is the gas. This is the gas created. Gas, why gas created from the flux? Flux here is evaporated. This one will be melted and deposited. Flux will be evaporated, create gas. This is a gas here surrounding. The gas here very important to protect the weld from further chemical reaction during the process. That's it. So this is here now solidification. While solidification, you can see that while solidification, you get the weld done. Right. This is, guys, is a consumable electrode. This is a consumable electrode. So this is a consumable electrode. Then consumable electrode, the core is, you can see that the core here, core is what? Core is a filler material and flux is surrounding material, right? Another type of consumable electrode could be consumable electrode. Consumable, what is a consumable, guys? What is a consumable? Mean melting and deposited as a filler. Electrode itself, no need to add it separate filler. Electrode itself will be melted and deposited as a filler. You can see that the consumable electrode could be rod. This is a one. We call it is a rod, welding rod. Could be welding rod. This is a welding rod, or could be wire. This is a wire. What is the difference between rod and wire? Welding rod, this is a welding rod. As I saw you previously, this is a welding rod. This is a welding rod. We call it sometimes stick. This is a welding rod, right? We call sometimes stick welding. Why? Because it is a stick, right? So this is a welding rod. This one must be changed frequently. This is a welding rod must be changed frequently. Why changing frequently? Because it is melted and depleted, and then when it finish, you must change this one and get new one. So you interfering, you have to stop the welding process and you change and so on. This is wasting a lot of time. The modification is a wire. The modification of this one is a wire. This is a weld wire. In a weld wire, you can see that it is continuous welding process. This is a wire. This is a wire. It is consumable also. Why consumable? Because this one will be melted and deposited. Same material. Same filler here is the same filler here, right? It is coming from spool. So it is continuously feed. It is continuously feed from spool. Then it will be melted and deposited. But it's very difficult here to coat. Very difficult to coat with the flux. Then no coating and no flux, because how to coat with the flux? It will be removed, and wounding in the spool, very difficult. Then this one continuously come from spool as a wire, just only wire, only filler. Someone will ask me, where is the flux? Flux here, we bring the flux here as a powder. So flux will be delivered here as a powder. This is a container. This is a hopper. We put the flux, and flux come here as a powder. We put flux here as a powder, covering the welding process. Covering the welding process. So consumable electrode could be welding rod, could be weld wire. What is the difference? Why we do like this? We do like this because this one continuous weld. We call it is continuous weld. No need to stop, because here this is very long length. The wire here is very long length, so it's coming continuously, so we consider as a continuous welding process. Non-consumable electrode. Now we come to non-consumable electrode. What is a non-consumable electrode? Non-consumable electrode, listen to me carefully. It is not consumed. What is that mean, not consumed? Not consumed mean it's not melting. Not consumed mean not melting during the welding process. So this is the electrode. Electrode here made of, remember, made of tungsten. All time made of tungsten. They call it TIG or GTAW. So made of tungsten. Always made of tungsten. Always made of tungsten. So electrode made of tungsten, and this tungsten is high melting temperature material. Temperature here up to melting temperature up to 3,500 degrees Celsius plus. Then very difficult to melt this one. This will not melted and not deposited in a weld. You have to add it filler. In this case, you must add it filler. This is the rod. This is a gun. This is a machine actually. This is a tungsten electrode. This is a tungsten electrode. This is a filler material you added. This will be melted and deposited as you can see here in a weld. Right. This one here we shielding by using gas. We shielding by using gas. We need to shield. We must shield. We must shield. So here we shielding by gas. Shielding by gas like inert gas. We're pumping here inert gas like helium, argon, CO2. And this inert gas will cover here to protect. But we shielding by gas. So electrode made of tungsten and we shielding by gas. That's why we call it TIG. TIG means tungsten inert gas. Tungsten inert gas, or GTAW means gas tungsten arc welding. Gas tungsten arc welding. It is still arc welding. This one also arc welding because here the charge happen between electrode and workpiece. Arc is created. This is the arc. So it is arc welding. So this one tungsten gas or gas tungsten arc welding. Previously also arc. So all arc welding, right? And we shielding by gas. We shielding by gas. No flux. We're not using flux here. So you can see that shielding. When we come to the shielding, generally in arc welding, we must shield. Please listen to me carefully. We must shield. Why we must shield? Because if you not shield mean protect. Shielding mean protecting. Because if you're not shielding, the quality will be very bad. Weld will react with the environment. You must shield. We shielding by either flux or gas. The only two ways to shield flux or gas. Gas like here, this is a continuous welding. Continuous here, this is a continuous welding. Continuous welding mean wire here is continuous. This is a consumable. For example, consumable electrode or non-consumable electrode. We shielding by flux also. Flux here, this is a flux. We added flux. We coating the electrode with a flux. So we use flux or we use gas. Flux or use gas. This is an example of flux. This is the arc welding here. You do arc welding here, and this is a flux. Flux is coating the filler material, and then they do here. And finally, as the end slag will be created, a layer will cover this one. A layer will cover this one. We call it slag, because the flux react with the environment, creating slag. Slag will cover, will become like this one is slag. Slag will cover this one manually. Later, after finish, manually this slag will be removed. This is a flux. This is a gas shielding. This is a gas shielding. Shielding here done by gas. So either we have to shield by flux or shielding by gas. We must shield by either by flux or by gas, right? To come to flux, flux is started by flux. As I told you, flux or gas. When you come to flux, flux could be boring. Flux could be boring here. Boring. Boring mean this is a wire electrode. This is a continuous wire electrode and no coating here. So boring, this is the hopper and the container. We put the flux inside. The flux will be boring. Boring mean we bring the flux as a powder and put here on the surface for welding. This is the first one, boring. Granular flux into welding operation. This is a boring or coating. So first one boring, second one stick or coating. Electrode coated with a flux here, coated with a flux as you can see. This is the second way to deliver flux. Third way we call tubular electrode. Tubular electrode, this is a tubular very similar to stick electrode. The big difference between tubular and stick electrode, here we coat with the flux as you can see, but here this one tubular mean in a core, the flux in the core. Not coating, but in the core. Someone will say, why we do that? Why we put the flux in the core? Why you simply coat easy? This one difficult to manufacturing because if temperature is high, this one will be delaminated and probably not functional well. Sometimes, some cases, if temperature is very high for any reason, the coated flux not functionally well. It is delaminated and sometime removed and sometime react with humidity and become unfunctionalized for any reason. Then they put in the core to maintain it, to protect the flux from anything and make it effective. They put in the core. It is difficult actually to manufacturing a more expensive. This is commonly used in industry. This being used in special cases when really we need to add some alloys in the flux. We need to protect the flux. So it could be boring like here. It could be stick or coated like here. It could be tubular being in the core like this one. This is the three ways to add the flux. Three ways to add the flux or three ways to apply flux in the electrode, right? The classification of the electrode classification. As you can see here, this is the electrode generally used in the welding. Electrode, there are a specification written here in electrode like EXXXX. E meaning electrode, E meaning electrode, XXX mean it here. This is the first two number to tell us about the electrode strength, the tensile strength of the coated material. This one is the position. This one is specify the current type and coating type. This one is the coating type. Coating type means this one, flux type. This one is the position, vertical position, tilting position, horizontal position, and so on. This one telling us the mechanical stress or tensile stress of the filler material that deposited in the weld joint. This one is the chemical composition of the filler. Chemical composition. As I told you, we must use the chemical composition matching with the substrate material because the vision welding it is limited to similar material. Never weld dissimilar material by vision welding generally. So you can see E is the electrode, 60 is the tensile strength. This is the tensile strength of the material, filler material. This is the position 1, 2. 0 here is the type of coating and current. This is the coating. Coating here, this one. This number, the last number here, describe the last number here, describe the type of coating. Last number here describe coating. Different type of coating being used as a flux. High cellulose sodium, high cellulose potassium, high titanium sodium, high titanium potassium. This is all being used as a flux. Then this one describes the type of the flux and type of the material to be added or to be used as a flux here. So this is the description of the electrode. Electrode coating flux here is electrode coating. Electrode coating is a flux being added as a flux. This is the most common type of welding being used in industry. Let you know why, because easy and cheap. This is cheap compared with any other method. However, this is also field method. Field means to be easily used in a field, portable method. The wire electrode or continuous electrode probably difficult to bring to the field. Maybe in a company, but in the field may be difficult. This is portable, easy, simple, and more cheap. And very common actually. Electrode, as I told you, electrode here, flux here, flux is a coating of the electrode. Very important to stabilize the arc. Stabilize the arc created, generating shielding gas. This is shielding gas created because this kind of flux react here, immediately evaporated and create a gas. This gas will react with the environment and create slag. This the yellow color one is a slag. Slag will be created and will be on the top of the surface to protect the weld, to protect further chemical reaction of the weld. This slag later, when weld finish, we remove manual, as I told you, control the rate of the deposition, act as a flux react with the environment, added some alloys. Sometime we added some alloys in a filler material, some little alloys in a filler material to improve the mechanical strength of the material. This is arc welding. Arc welding power, generally, arc welding power could be AC or DC. AC is little used. It is is less expensive actually. AC is cheap, but AC is not functionalized better like DC. DC is more functionalized or more general, more be general used in welding. Most commonly used in welding is the DC equipment or DC current or DC power supply, and can be used for all metal. But this one AC is always used with ferrous material. AC always used only with ferrous material. DC is more common, more expensive, but this one very commonly used, can be used with all material. The power delivered as a source in arc welding, listen to me carefully. In arc welding, the power delivered at the source is IE. Power delivered at the source is IE, because current here, current I pass through the arc. Current I pass through the arc at voltage E. Then IE is the power delivered at the source. So this is the power. Power mean what? Meaning joule per second, meaning heat rate. Then the heat rate generated at the source, and listen to me carefully, at the source is IE. This one we can use the power at the source. The power at the source, or the heat rate, watt or joule per second, generated at the source equal to IE. Then we can use what we use. We use RHW equation, because this is a power equation or heat rate equations. And RHW equal to F1 F2 RH. RH is the heat rate generated at the source. This is the heat rate generated at the weld, equal to F1 F2. This is the transfer factor. This is the melting factor. RH equal to UMAV. A welding area, V is welding speed. Then RH here equal to IE. Then in case of arc welding, only arc welding, in case of only arc welding, RHW equal to F1 F2 IE, current multiplied by voltage, equal to UMAWV. This is a modification, little modification. Equation is same, just only the power created or generated at source equal to IE. Okay, this one leading to an example. Let's take an example and try to solve this example together. Let's try to read and understand. Let's try to read and understand together. Please give me your attention. Please give me your attention to read this one and understand. A gas tungsten arc welding. It doesn't matter. It doesn't matter what arc welding, just arc welding. If you read arc welding, If you find arc welding, then as long as it is arc welding, then if it is as long as arc welding, then IE. What arc welding? No matter. Gas, tungsten arc welding, shielded metal arc welding, whatever arc welding, as long as it is arc welding, then power at the source equal to IE. Right. So a gas tungsten arc welding, let me read together a gas tungsten arc welding operation. Okay. This is the gas tungsten arc welding. This is the tungsten. This is the electrode. Gas tungsten mean electrode made of tungsten. This is non-consumable electrode. Gas made of tungsten and arc welding here. Arc welding here. So a gas tungsten arc welding operation is performed at current I equal to 300 ampere. Voltage is 20 volt. IE. This is I. This is E. Then 300 multiplied by 20. Then you can understand immediately the power delivered at the source, equal to 300 multiplied by 20, then 300 multiplied by 20, IE, then you get 6,000 watt. 6,000 watt is the power delivered at the source. Melting factor F2 is given. Melting factor is 0.5. F1 also is given. F1 here we obtain from the table, just consider as given, is 0.7. This is a 0.1, is F1 is 0.7, F2 is 0.5, and unit melt UM also is given. UM is given 10 joule per cubic millimeter. UM is given, which is a unit melt. Determine what is the power in the operation. Power in the operation, which is at the source, equal to 6,000 watt. This is the first question. What is the power in the operation, or what is the power at the source? Second, what is the rate of heat generated? Rate of the heat mean power generated at the weld, or rate of heat generated at the weld. Same meaning, right? What is the rate of heat? Rate of heat means joule per second. Joule per second, or what? Rate of heat generated at the weld mean RHW. Here, then what is the RHW? RHW equal to F1, F2, IE, or power at the source, 6,000 watt. Then 0.7 multiplied by 0.5 multiplied by 6,000, then 2,100 watt delivered at, or heat generated at weld. This is the heat generated at weld. Please understand. This is the heat generated at the weld. This 6,000 is generated at the source. So you can see that 6,000 generated at the source, 2,100 generated at the weld, or delivered to the weld. Volume, the last question, what is the volume rate of metal weld? Volume rate mean cubic millimeter per second. What is the volume rate? Cubic millimeter per second. Volume rate of the weld. Volume rate of the weld actually can be obtained RHW equal to UMAW. AW, which is the weld area multiplied by the velocity. This one AWV, which is the RWV, which is the cubic millimeter per second. This one this is 1 millimeter square. This 1 millimeter per second, cubic millimeter per second. So cubic millimeter per second. Then AW, we need to obtain AW value. This one. Then RHW we know, which is 2,100. UM we know UM. We know UM, unit melt is given, and RHW we know, which is this one. Then simply RWV, which is a cubic millimeter per second, equal to RHW divided by UM. Then it is 210. It is 210 cubic millimeter per second. This is the volume of weld metal. This is the volume of metal delivered. This is the volume of metal welded. The volume of metal welded, or volume rate. Let's say volume rate of metal weld. Volume rate means every second 210 cubic millimeter of material will be welded. Volume rate of metal weld. Right. Any question? Guys, any question? Clear? Okay, that's it. Arc welding, there are many arc welding actually. Then we're going to focus on that, or we're going to show. We call it shielded metal arc welding, and listen to me very carefully to differentiate between this. But all of them arc welding. All of them arc welding. Arc welding mean what? Arc welding mean IE. Either it is shielded metal arc welding, gas metal arc welding, flux core arc welding, electro gas arc welding, submerged arc welding. It doesn't matter. It doesn't matter. As it is arc welding, it is IE. Then going to consumable electrode. First, arc welding. All these methods, 1, 2, 3, 4, 5 methods are consumable electrode. All these methods that we're going to discuss are consumable. Later, we will talk about non-consumable electrode. So we'll start first with consumable electrode methods. After that, we will move to non-consumable electrode method. We have 5 methods in consumable electrodes that we're going to discuss. This is a consumable electrode, as you can see here. Definitely, this is a holder, this is a electrode, and this is a workpiece material, and so on, as we described earlier. Start with the shielded metal arc welding. This is a shielded metal arc welding. First method. First method, shielded metal arc welding. SMAW, shielded metal arc welding. Consumable shielded metal arc welding. The word shielded metal arc welding refers to this one. This is a shielded metal arc welding. Shielded because it is coated with a flux. Metal because core, listen to me carefully, core made of metal. What metal? Compatible with the material that you weld. If you weld steel, it will be steel. Aluminium, copper must be compatible with the material that you weld. It is for similar material. It is for similar material. So when said metal, the word metal here meaning core, which is filler, is metal compatible with this one. So shielded metal arc welding. This is whatever we call shielded metal arc welding. Right. Shielded metal arc welding. This is a shielded metal. Here describing what already we described earlier. This is the electrode. This is the holder. We connect the electricity. Then arc will be created. This one will melted and deposited. This one will be evaporated and creating gas, and slag will be created, and so on. I believe you are. So shielded metal arc welding. This one we call it shielded metal arc welding. Right. In a shielded metal arc welding, we have a 2 type. In shielded metal arc welding, we have 2 types. We call it straight polarity and we call it reverse polarity. Straight polarity and reverse polarity. This one is straight polarity. This one is reverse polarity. What is the difference? What is the difference between straight polarity and reverse polarity? Please give me your attention. Please give me your attention to understand. In straight polarity, current will move through electrode to the workpiece. Current will move through electrode to workpiece. In reverse polarity, current will move through the workpiece to the electrode. Current will move through the workpiece to electrode. What is the difference? Yeah. The difference is that when current moves through the electrode, sorry, big current will be accumulated here. Current will accumulate here, leading to very high melting temperature here. Very high temperature here, leading to melt this one quickly, deposit a lot of material, electrode material in the weld zone. In a weld zone. And this one is good for sheet metal welding. Sheet metal means small thickness. So it deposit big amount of weld here. Deposit big amount of weld here. So the weld you can find it is shallow. Shallow, not deep. Shallow and wide. Shallow and wide. Mubarak, just give me a minute and ask me, no problem. Then temperature will be very high here. melting big amount, and then the weld will be shallow and wide. In this case, the electrode, the current pass through the workpiece to electrode mean the temperature will become very high in here in a workpiece. This one leading that the workpiece will melt it easily, quickly melt, and then this one is better in case of deep weld. This one better in deep weld. This one better in whatever we call is a sheet metal, mean small thickness sheet metal weld. This one is more better in sheet metal weld. This one is more better in deep welding. Deep welding mean bigger thickness of the workpiece material. This is a big difference between straight polarity and reverse polarity. Mubarak, yes, I'm listening. Mubarak, you would like to ask, right? Okay, right. So this is a big difference between the straight polarity and the reverse polarity in the shielded metal arc welding. And next is the submerged arc welding. Submerged consumable electrode. Next in consumable electrode is submerged arc welding. We call it submerged arc welding because this is a method of continuous wire. Continuous wire is coming here, right? Continuous wire is coming here. We deliver the flux as a powder. Then the flux, we put the flux here. That's why we call it submerged arc welding. Why submerged? Submerged يعني غطسان يعني الويلدنج تحت متغطي أو covered by the flux. That's why we call it submerged arc welding. So submerged arc welding we cover with the flux, so it is a continuous welding process. This is a wire, continuous wire coming from the spool here, and this is the flux. We bring the flux here, we deliver the flux here to cover, and then weld done below the flux. So it is submerged. We have two tubes, one to deliver, this one to deliver the flux here, this one to take out the extra flux not used, because some flux will be melted and worked here and create slag. Some powder will not be used. You can take this kind of extra powder by using the other you can take it. This one we call recovery tube, and this one you can use this one to remove the additional one. Let me show you submerged. Let me show you this video. Yep. Right. Okay. This is a material that you would like to weld. This is a material that you would like to weld. This is a wire, continuous wire. This is a wire. It is continuous, as I told you. It is continuous wire electrode. This is a flux. This tube to bring the flux. This another tube to collect. We call it recovery tube. Recovery tube to take out whatever extra flux not being used, right? Here we added flux. This tube is to deliver flux, to bring the flux. So if we added flux here, this is a flux material. This is a flux material, and now this is a wire electrode. We bring wire electrode. Electrode will approach here, become closed. Then arc is created. Arc is created here. Welding will be done. Some of flux will be used, some flux will not be used. Then weld done. This one will take out the additional flux that not used in the welding process. Additional flux not used in the welding process. So we call it submerged arc welding. We call it submerged arc welding. So this is a submerged. Submerged, why submerged? Because here it done below the flux is covering. However, This is good actually, but limited to horizontal and flat weld. Limited to horizontal and flat weld. Yes, Muhammad.
Doctor, can you gather the links for the videos and post it in one small file, the Blackboard?
Yeah, I can add the link actually. The
يعني
link
بس
to
كده
put
ملفات حق اللينكس بس.
يا ممكن نكون نحط اللينك في المحاضرة وبعدين انت تعمل كليك على اللينك تشوف الفيديو. كل ده على اليوتيوب by the way. I bring this one from YouTube. So you will find in the tube. If you make search by yourself, you find. But I will add the link. Hopefully, I will add the link to the notes. Then you can just click the link. You can just get the video. Yeah, fine, no problem. Inshallah.
Okay, thank
This
you.
one limited to horizontal. Horizontal. Why horizontal? Because you put powder here. If you try to make it vertical, this powder will not be okay. Then this one limited to horizontal. Well, this one high weld quality and productivity is okay. It's like automated and continuous welding process, and productivity is higher, quality is good, and so on. But the problem is this one limited to horizontal weld. Limited to horizontal weld. The improvement actually, just give me 2 minutes to. The improvement is this one. Gas metal arc welding. This is the improvement of the submerged arc welding. What is the difference between gas metal arc welding and submerged arc welding? The only difference it is here, this is a spool also. This is a spool also. And this is a wire. Continuous wire come from the spool. This is a consumable electrode. The only difference between this one and the other one here, we shielding by gas. Why? Because to improve other one you put powder, and this powder is like a big headache, and this one horizontal and cannot be tilted or vertical. Now we shielding by gas, then it is easy. So we call gas metal. Word metal here is not tungsten. If I said gas tungsten, it is non-consumable because tungsten will refer to the electrode. But I said here gas metal, then you can understand that electrode is metal. Metal, what metal? Compatible with the workpiece material. If I said gas tungsten arc welding, then made the electrode made of tungsten, and this one non-consumable electrode. But if I said gas metal, it is consumable electrode. Then this one continuous feed of the wire from the spool, and we pumping gas here, to shield here, and gas which is argon, helium, and CO2 for different material and so on. This kind of improvement of the submerged arc welding. Next is flux cored arc welding. I will stop here. This one also, I think we also discussed this one. The only difference here, the flux. Flux is in the core, not in covering, and this is, as I told you, is more flexible to protect and so on. This is whatever we call flux cored arc welding, as I described earlier. Next is electroslag welding. I will stop here. Next time, inshallah, I'll talk about consumable electroslag welding process.